So in all the examples we have looked at so far, we have worked with single self-contained documents. But in the real world, the entities and concepts that we work with, they have some kind of association. For example, you can have a course object or a course document, and of course, this course has an author. But an author is more than just a name, it's more than just a simple string. You might have a collection of authors where we store author documents, and in each author document, we can have properties like name, website, image, and so on. So in this lecture, I'm going to talk about how to work with related objects. Basically, we have two approaches. One is using references, which we call normalization. And the other approach is using embedded documents, which we call denormalization. So let's see how these work. With the first approach, we should have a separate collection for storing our authors. So we can have an author object like this. Here we have all kinds of properties. And then we'll have a separate collection where we store course objects like this. So here we have a course object. We set the author to the ID of an author document in authors collection. So here we are using a reference. Now I need to clarify something here. In relational databases, we have this concept of relationship which enforces data integrity. But in MongoDB or NoSQL databases in general, we don't really have a relationship. So even though I'm setting the ID of an author here, there's actually no association or no relationship between these two documents in the database. In other words, I can set this to an invalid ID, and Mongo doesn't care about that. Now, we could take this example to the next level. Let's say a course might have multiple authors. So instead of the author property, we could have authors, which we set to an array of references. So here, we'll store multiple IDs. Now, for simplicity, let's just work with a single author. So I'm going to delete this part. So this is our first approach, which involves using references. There is another approach. Instead of having a separate collection of authors, we can embed an author document inside of a course document. So here we can have a course object or a course document. In this document, we have the author property, and we set this to an object. So here we'll have all the properties of an author. So we are embedding a document inside of another document, okay? And this is what we call denormalization. Now, if you have never worked with NoSQL databases before and you come from a relational database background, you may think that the first approach is the way to go. But that's not necessarily the case when working with NoSQL databases. Each approach has its strengths and weaknesses. What approach you choose really depends on your application and its querying requirements. So basically, you need to do a trade-off between query performance versus consistency. Let me explain what I mean by that. With the first approach, we have a single place to define an author. If tomorrow I decide to change the name of this author from Mosh to Mosh Hamedani, there is a single place that I need to modify. And all courses that are referencing that author will immediately see the updated author. So with the first approach, we have consistency. However, every time we want to query a course, we need to do an extra query to load the related author. Now, sometimes that extra query may not be a big deal, but in certain situations, you want to make sure that your queries run as fast as possible. If that's the case, you need to look at the second approach using embedded documents. So with this approach, we can load a course object and its author using a single query. We don't have to do an additional query to load the author because author is inside the course object or the course document. However, with this approach, if tomorrow I decide to change the name of this author from Mosh to Mosh Hamedani, chances are there are multiple course documents that need to be updated. And if our update operation doesn't complete successfully, it is possible that we'll have some course documents that are not updated. So we'll end up with inconsistent data. So the first approach gives us consistency. The second approach gives us performance. That's why I told you that you need to do a trade-off between consistency and performance. You can't have both of them at the same time. So in every part of your application, you need to think about the queries you're going to execute ahead of time. And you will design your database based on those queries. So these are the general principles. Now we have a third approach, which we call the hybrid approach. For example, imagine each author has 50 properties. We don't want to duplicate all those properties inside every course in our database. So we can have a separate collection of authors, but instead of using a reference here, we can embed an author document inside of a course document, but not the complete representation of that author. Perhaps we only want the name property. So with the hybrid approach, our database will look like this. So we have a collection of authors. In this collection, we'll have author objects like this. So we have the name, Mosh, and here we'll have 50 other properties. Now we'll have a separate collection of courses. In this collection, we'll have course documents like this. So author, we set this to a document. And in this document, we'll have only two properties. One is ID. That is a reference to an author document. We also have name. With this approach, we can quickly read a course object along with its author, so we can optimize our query performance, but we don't have to store all those properties of an author inside a course document. Now, this approach is particularly useful if you want to have a snapshot of your data at a point in time. For example, imagine you're designing an e-commerce application. There we'll have collections like orders, products, shopping carts, and so on. In each order, we need to store a snapshot of a product because we want to know the price of that product at a given point in time. So that's where we'll use the hybrid approach. So once again, which approach you choose really depends on the application you're building. There's no right or wrong. Each approach has its strengths and weaknesses. Over the next few lectures, I'm going to show you how to implement each of these approaches.